Hello everyone. In this video, we are going to look at Chapter 7, Section 17.2 and Section 17.2 and 17.3. In this section, we're going to apply the three equations of motion for rigid body in the planar motion. We're going to apply problems involving translating motion. Translating. So we're not rotating in this section. Um, let's see. Equations for translating motion, you have if a body undergoes the translating motion, equation says F equals mag. This could be also written in the scalar form, which on the x direction you have Fx equals magx, and then on the y direction you have Fy equals magy. In words, the sum of all the external forces acting on the body is equal to the body's mass times the acceleration of the mass center. So Newton's second law, in short. We need to determine the effect caused by the moment of an external force system. The moment about point P can be written as sigma r cross F plus sigma mi equals r cross mag plus ig alpha. And over here, you have sigma mp equals sigma mkp. So over here, the r equals xi plus j yj, and then sigma mp is the resultant moment about point P due to all the external forces. And notice that this is about P. And then the term sigma mkp is called the kinetic moment about point P. If a point, if this point is in the center of mass G is the same point, this equation reduced to the scalar equation sigma mg equals ig alpha. In other words, resultant or the summation moment about the mass center due to all the external forces is equal to the moment of inertia about g times the angular acceleration of the body. So three independent scalar equations of motion may be used to describe the general planar motion of the rigid body. These equations are sigma fx equals magx, sigma fy equals magy, and sigma mg equals ig alpha, or over here sigma mp equals sigma mkp. Um, Under the condition that rigid body only has translation motion, all the particles of the body have the same acceleration, so ag equals a and alpha equal to 0. The equations of motion become sigma fx equals magx, sigma fy equals magy, mg sigma mg equal to 0. And notice that if it makes the problem easier, the moment equation can be applied about another point instead of the mass center. For example, if any random point A is chosen, you can do sigma ma equals mag times d. When a rigid body is curvilinear motion, so if it is rotating somehow under a curve, we can also use this anti-coordinate system. And with using the anti-coordinate system, we have Fn equals magn, Ft equals magt. So this still you have sigma mg equal to 0 or sigma mb equals e m ag on the t direction minus h times mag on the n direction. For problems like this, general steps to follow, general procedures to follow, we're going to establish an xy coordinate or nt coordinate, depends on your problem. And then step number 2, draw the free body diagram and the kinetic diagram showing all the external forces, couples, and the inertial forces and couples. Identify the unknowns, apply the three equations of motion. You have fx equals max, fy equals may, and then on the if it's anti coordinate system, you will have Fn equals magn, Ft equals magt. And then down here overall, but both of them share those two equations about the moment, either about the center of gravity, sigma mg equal to 0, or if it's a point P, sigma P equals sigma mkp. Remember, friction forces always act on the body, opposing the motion of the body. Let's take a look at some examples together. This one right here, we know the car is not going to rotate. If it's not rotating, you know what to do. We're going to draw our free body diagram, kinetic diagram, and we write our equation. Not rotating, meaning your last is sigma mg equal to 0. Okay, so free body diagram, and then we're going to put sum of all the forces together on the horizontal direction. And notice that you have a 100 Newton coming down at an angle. We're going to break it into the horizontal component and the vertical component. Horizontal component is on your x, is the only force x, force on the x direction. That equals magx, so that's 100 ag, and then that will help us calculate the ag. And then you have an equation on the vertical direction. Vertical direction, you have NA and B going up, the weight coming down, and you have a negative 100 times 3/5. And then this gives you an equation of NA, normal force A, normal force B together. And you have a summation of moment about point G. And then this about point G, be careful, it's always going to be the force multiplied by the moment R. For example, this one right here, NA, right? We're looking at about point G right here in the middle. Force times the moment R. Moment R is going to be the perpendicular distance from NA to G, from G to NA perpendicular distance, which is 0.6. And this NA is trying, it may not actually rotate, but it's trying to rotate about point G. This direction is counterclockwise, meaning this is going to be a positive value. And then NB, I'm going to use a different color. NB, you have NB multiplied by the perpendicular distance, which will be 0.4. But this thing right here is trying to rotate the opposite way. This is the green one, NB rotating about point G. That's clockwise. That's why you have a negative sign here. Okay, similarly, you're going to do that for 100. 100, be careful, it's at an angle, so we're breaking that 100 into two different parts, horizontal component and the vertical component, and then look at their moment arms separately and look at that if they are trying to rotate about point G clockwise or counterclockwise separately. And we can, from these two equations, we can solve for the NA and NB, two equations and two unknowns. Okay, next problem. Again, we know this truck is not going to rotate, and we first gonna, that means sigma mg equal to 0, right? Not rotating, so we draw our free body diagram. Notice that there's friction on the floor because the friction coefficient, static friction coefficient, is given to us, okay? And friction on the floor, we're gonna need to label them both on the location A and B. And then you have your free body diagram, normal force, friction, friction, and then the weight coming down. Overall, you have your magx. And then we can write our relationship between the FA, FB together with the friction coefficient and the normal NA and B. And then over here, we write our equation, sum of all the forces on the horizontal direction, sum of all the forces on the vertical direction, and you do a sum of the moment about point G. And again, be careful when you do the sigma mg equal to 0, be careful with the moment arm, be careful with the, is it clockwise, counterclockwise, make it negative or positive. For example, I will show you one as an example. This one right here, this is the friction 0.2 times NA, which is this force right here, this one right here, okay? And the moment arm will be perpendicular distance from point G to location A, which is this distance right here. That is 0.75, okay? So 0.2 NA times 0.75. And this one right here, if you follow the direction of that arrow, that friction's to the right, right? Follow the direction about that arrow about point G, this is going counterclockwise. That's why the first term right here is positive. Okay, so two equations and two unknowns. With the last one, if after we figure out NA and NB, we can figure out the value of AG. Okay. And then group problem, lastly, this one right here, we know again it's not going to rotate, not rotating. Okay, now free body diagram, we'll have normal force AB, weight coming down, and then there's this force pulling at an angle. Write our force, summation of force along the horizontal direction. Notice that we are breaking that 300 Newton into horizontal and vertical. And then we also write our force into the vertical direction. Since notice that, vertical direction, this cart is only moving, any movement is on the horizontal direction. That's why any of your MAGY is 0. There's no movement on the vertical direction. And we're doing a summation of G about 0.0. And then overall, we have be careful with with the moment arm, and is it clockwise or counterclockwise, make it negative or positive. And then the normal force, two equations and two unknowns, we can solve for the NA and the NB. Okay, that's all I want to share with you in this video. Hope you find it helpful, and thank you for watching.